Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a good day to each and everyone once again. Um okay, so for today's videos we will continue our discussion for our last meeting. Okay? So our topic for last meeting, no, previously is about the first law of thermodynamics and the generalization or the derivation of energy equation. Okay, so the energy equation probably involves um the heat that is being transferred from or to the system considered in the work done on the system, or the work done by the system, and the internal energy and the kinetic and potential energy. Okay, so we also consider the simplification of our energy equation, okay, using first law of thermodynamics. Okay, and we also discuss the some characteristic or some properties of a substance that is being stated or that is being found on our table, okay, on appendix of our books that we are using. Okay, so for now this will be the continuation of the topics. Okay, this again still okay, talks about the first law of thermodynamics and the energy equation, but this will be the continuation of our last topics. Okay, so dito tayo sa number 1, proceed tayo. So dito sa number 1 we have problem analysis and solution technique. Okay, so basahin na lang natin to siya. Most probably this technique talks about how we can uh, derive, okay, if we have a given question that is required to find the final answer. Okay, the final question or the final required quantities, we have to follow this techniques here, or the steps here, to effectively found the final answers of our required quantities. Okay, if we have given question. Okay, so okay, so dito tayo sa example number 1. Okay, so dito sa example number 1, talks about a vessel having a volume of 5 meter cube contains 0.05 meter cube of saturated liquid water and 4.95 meter cube of saturated water vapor at 0.1 megapascal. Heat is transferred until the vessel is filled with the saturated vapor. Okay, so determine the heat transfer for this process. So probably the state 1 here is the combination of saturated liquid and saturated vapor. Then we have to transform some or we have to transfer some value of heat here, no, papunta sa system natin to fully filled the vessel by saturated vapor. Okay, so take note that saturated vapor, hindi pa yun siya naging superheated vapor. So still, we have to find the characteristic of the state 2 from the saturated liquid and vapor table. Okay? So yun. So ito yung step 1 dito, no? Ito yung mga step by step na gagawin, no? Based on our step by step dito na gi-indicate dito sa number 1. Okay? So we have here control mass. So we have all the water inside the vessel. Okay, so ibig sabihin you have to identify the control mass, no, in the case of this problem. So in here, our control mass here is the vessel, no, or water inside the vessel. Okay, so sketch is ito, 3.17, ito yung sketch natin. Initial state, we have the given for our initial state is the pressure, no, yung saturated water vapor, in which ito yan siya. Okay, tapos pressure, the volume of the liquid, volume of the vapor, saturated state 1 is fixed. Okay, makukuha natin yung volume ng liquid at saka yung volume ng vapor by using the table, no? And then okay, so yun, the final state naman is somewhere along the saturated vapor curve. Okay, the water was heated, so therefore uh, uh, the pressure at the state 2 is much greater than P1. Okay, so siyempre, so process, no, that we have here constant volume and mass, therefore constant specific volume. No, constant yung volume natin kasi vessel yung ginamit dito na nilalagyan ng water. So pag sinabi mong vessel, hindi na siya nagbabago, okay? Then diagram, ito yung diagram natin, 3.18. Okay, tapos model is steam table. Steam table pa rin tayo kasi we are talking about here water, okay? So yun. Okay. Now, for analysis, now from the energy equation we have U2. No, this is from energy equation. Internal energy at state 2 minus internal energy at state 1 plus the kinetic energy and the potential energy is equals to transfer of heat minus transfer of work. Okay. So by examining the control surface for various work modes, the conclude we conclude that the work for this process is zero. Yes, tama kasi wala naman tayong movement of boundary eh. Hindi naman nag-move yung kuan natin, no? Yung vessels natin or yung volume natin. So furthermore, the system is not moving. So there is no change in kinetic energy, no? So wala rin tayong change of kinetic energy since wala tayong movement. Tapos there is small change in the center of mass of the system, but we will assume that the corresponding change in potential energy in kilojoules is negligible. Okay, so ni-neglect din natin yung uh, potential energy due to change of center center mass ng system natin. Okay, kasi maliit lang naman yan. So therefore, the energy equation is equal to this one, no? Or the energy equation will become this equation here na transfer of energy is equals to change of internal energy. Okay? So this will be the solution. We have the heat transfer will be found from the energy equation. State 1 is known, so U1 can be calculated, no, as I have said. So the specific volume at state 2 is also known, no, from state 1 in the process. Since the state 2 is saturated vapor, state 2 is fixed as seen in figure 3.18. Therefore, U2 can also be found. Yes, no, yun. Now, for us to be able to find the internal energy and at state 1, we have to find the mass of the liquid and the mass of the vapor, syempre, no? So, if for us to be able to find the mass of the liquid and the mass of the vapor, we have to find, since given yung liquid volume natin, we have to find the specific volume of our liquid at saka specific volume ng ating vapor, no? As you can see here, ito. No, ito yung kinuha natin sa table, itong VF at saka yung VG. So yung V liquid at saka VB vapor is given yun siya sa problem natin. Okay? Given yun siya sa problem natin. Okay. So U1 is equals to mass 1 liquid and U1 liquid. Okay, so yun. Gagamitin lang natin yung equation natin for our internal energy. And after that, makukuha na natin yung total internal energy at state 1. So same for to determine the U2, we need to know the thermodynamics properties since this determines the final state. The properties we know are the quality X, no? We have the 100% as I have said kasi yung result natin sa state 2 is saturated vapor. So hindi pa yun sa naging superheated vapor. Take note of that. So since saturated vapor siya, fully saturated vapor, so ibig sabihin nun, ang X natin is 100%. Okay? So, yun. So, and V2, the final state, the final specific volume, therefore, which can readily be determined. Okay? We have mass of the liquid is equals to plus mass of the vapor. Okay? But since yung volume natin is constant pa rin, 5.0, so makuha natin yung specific volume at state 2. Okay? Then, after nun, pag makuha na natin yung specific volume at state 2, we can now find the value of internal energy at table B.1.2 using the given pressure, okay, sa problem at saka yung VG na nakuha natin dito, okay? Okay? Yung VG or yung specific volume ng superheated saturated vapor. No, makukuha natin yung internal energy doon. Then after doon, ito na yun siyang internal energy natin since given naman yung mass natin, mass ng total. Okay, so yun, makukuha natin yung total internal energy, no? Actually, dito sa table B.1.2, ang makukuha natin is yung specific internal energy, yung small letter U. Okay? So, as you can see, kilojoule per kilogram pa yan siya. So, we have to multiply that one by mass for to be able to have a kilojoule lang dapat, no? Yun. So, therefore, makukuha na natin yung transfer of energy. Okay? I mean, transfer of heat. Okay? So, for this example number 2, the same lang naman sa example number 1. So, basahin na lang natin to siya. Okay? So, for example number 3 naman, same pa rin. Okay, ganun pa rin yung gagawin. Okay, ifa-follow lang natin yung step by step na binanggit doon sa step number 1. Then yun. Okay, so makukuha na natin yung final answer. Okay, so basahin na lang natin yun siya.